Hi guys, this is the 10B notes, and we are doing example number 6. Now, the question asks us to find both missing sides. Up till now, we've often had a variable, an x, on one of the sides, and had to find one missing side. But how do we find two missing sides? Well, let's go ahead and get started. The first thing I want you to do is to always write your SOHCAHTOA. SOHCAHTOA, and that's going to help you remember what your trig identities are. All of those important: sine, cos, and tan, the trig identities. We want to make sure we know what we're looking for. We're looking for both sides. So let's go ahead and assign some variables. So we'll call this side x, and let's go ahead and call this other side y. Okay? Now, here's what I want you to do when you're doing problems like this. I actually want you to draw the triangle again. Now, luckily, I'm on a computer program. I can just copy it. But on your paper, I want you to copy that problem again. And I want you to pick one of them to work the x and one of them to work the y. So I'm going to go ahead and I'm going to work the x on this first one, and I'm going to work the y on the second one. And I'm going to show you the reason why having two triangles for the same problem is useful. So let's go ahead and label this triangle first. Okay? That long side across from our 90-degree angle, we label with a capital H. We're then going to find out the angle that we're looking at. It's over here. This one, it doesn't have a theta. It's got an angle measure, but we do label those legs with respect to that angle. So this side that's touching that angle, we want to call the adjacent side. We'll label that with a capital A, not to be confused with this A. I'm going to go ahead and change the color. So this is the adjacent side. All the way across the triangle from that angle is the side that we call the opposite side, and we label with that capital O. So here's the labeling for this triangle based on the fact that we're interested in this angle over here. Now, same with this side. We are going to do the same thing. Now, even though we're interested in the hypotenuse over here, the labeling is the same. That's because our angle is the same, isn't it? And, of course, that side touching the angle is our adjacent side. All the way across the triangle, we have the opposite side. Now, let's look at this first question. We want to find x. So what I'm going to do is I am going to circle my x to remind myself that that's what I'm looking for when I'm working over here. When I'm working over here, I'm going to look for my y. And I'm also going to just split my problem. And I'm going to just do two completely different problems. And I think that's an easy way to keep everything straight. Now, if you want to come up with a different system that works for you, go for it. When we're looking for this side x, we have the opposite side that the variable's on, and the adjacent side where we have a length measurement, 6. So the opposite and the adjacent. The trig identity that deals with opposite and adjacent is tan. So the one we're going to use is tan of theta. Tan of theta is equal to the opposite side divided by the adjacent side. That's the trig identity that I'll use for that one. Now, just to sort of compare, let's look at this second one. What would be the trig identity that we should use over here? Well, our variable is on our hypotenuse. And then our side length is on our adjacent. So we're looking for something, a trig identity using the adjacent and hypotenuse. Okay, that's our cosine. So the cosine of theta is going to be equal to the adjacent side over the hypotenuse. Let's come back to this first triangle and plug in the information we have. But already you can see that we're going in different directions here because of the fact that we're interested in using a trig identity that helps us with different sides depending on the side we're looking for. Okay? Now over here looking for x, let's substitute in for theta. We know the value for theta, so we can write the tan, instead of using that variable theta, we'll use 53 degrees. The opposite side is where we have our variable x, and the adjacent side we know is 6 long. We can use Desmos to find out what the tan of 53 degrees is. We'll make sure that we're in degree mode. Then we'll go into our functions and hit tan 63. And you can see that we'll have 1.96 because that third spot is a 2. We'll leave that 6 alone. 1.96. Tan of 53 degrees. Oops, I think I might have done 63 degrees. So I want to double check. I did. We'll make sure that we're at 53 degrees. Here we've got 1.32, but the third spot is a 7. It's 5 or above, so I'm going to bump that 2, and that'll give me 1.33 for the tangent of 53 degrees. 1.33. Sorry about that, guys. The tangent of 53 degrees is 1.33. And that'll be equal to x over 6. Now, I want to solve for x, so I'm going to say, what's being done to x? And when you have this line and the 6 underneath, well, you know that that's division. X is being divided by 6. So I want to do the opposite, and I'll multiply by 6. Of course, do that to both sides. Up 6 and down 6 will cancel, and I will get x. It will equal 6 times 1.33. And that is 7.98. So x is 7.98. Now let's come over here and finish up for y. The cosine of theta over here, that's what the trig identity we decided to use. We'll plug in, same degrees here, but now we're in cosine. The cosine of theta, which in this triangle is 53 degrees as well, is equal to the adjacent side, which is 6, over our hypotenuse, which is the variable y. Let's find what cosine of 53 degrees is. We'll come back over here again. Make sure you're in degrees. I know I am. Cosine of 53 degrees is 0.60, and we'll leave it as a 0 because that third spot is a 1. 0.60 is what the cosine of 53 degrees is, 0.60. And that's equal to 6 divided by our variable, which is y. Now, here again, we've got a variable in the bottom. So what we want to do to get it out of there, we just want to multiply both sides by that variable. And remember, when we're multiplying a fraction, underneath that y is a 1. So that's definitely up y, right? Up y and down y are going to cancel. They'll divide out to 1. We'll multiply this side by y, which will give us 0.60y. These multiplied equals, what do we have left? 6 over 1, or 6. Now we want to get y by itself. It's being multiplied by 0.60. So we'll do the opposite operation. Instead of multiply, will divide, and always to both sides. Up 0.60 cancels down 0.60. They'll divide out to 1. And we'll have y equals 6 divided by 0.60. 6 divided by 0.60. And that will give us 10. The y variable is our hypotenuse, and that means our hypotenuse is 10 long. Y is equal to 10. So that's how you do these problems where you're looking for both missing sides. I think it's easier if you draw that triangle a second time and keep everything nice and separate, realizing that depending on what side you're looking for, you are going to use a different trig identity. All right, guys, thanks for watching.